We've got another problem up here on the board. We're given this rational function f of x, and we're asked to prove that the limit as x goes to -1 of f of x is -4. Now, I said I'm only going to hold you responsible for formal epsilon delta proofs if you have a linear function or an almost linear function, if the graph of your function is a line with a hole in it. That's actually what we're going to have here. This is a rational function, but I can write it, I can simplify it, and when I simplify it, I'll be able to see that it's in that category. What I would do is I would factor. So I can factor out a 2 on the top. And then this difference of squares I can factor again. So the top is 2 times x plus 1 times x minus 1, and the bottom is x plus 1. Now, if I cancel that x plus 1 on the top, what I'm left with is 2x minus 2. I just distributed that 2 back in, but I must record that that's only true if x isn't -1. Right? I'm not writing the word limit in front of these. I'm just talking about the function. This function is not a linear function, but its graph is going to be a line with a hole in it. Okay, excellent. So let's start with the informal part. So remember, if we're given an epsilon that's bigger than 0, so that's our challenge. Somebody says, I bet you can't make the y values of f that close to -4. And we're going to meet that challenge. Our goal now is to find a delta bigger than 0, so that if 0 is less than the absolute value of x minus a -1 is less than delta. So remember, this says that x is close to -1 using delta as our standard of closeness. This part says x is not equal to -1. And for this problem, that's going to be important. In our last problem, we wrote this because we wanted to show that we were exactly matching the definition, and it's part of the definition, but we didn't really need to use this part of the inequality. Now we're going to need that. Okay. And we're trying to find a delta so that if this inequality is true, then the absolute value of f of x minus a -4 will be smaller than epsilon. Okay, a little bit of work over here. I'm going to just observe that I can simplify this to x plus 1 in the middle. Okay, that's still representing the distance between x and -1. And this part of the inequality is going to tell me that x is not -1. And therefore, I can replace f of x with 2x minus 2. I can't do that unless I know that x isn't -1, because this is part of the definition of f, that -1 is not in the domain. Okay, so I'm going to be using that this time. And here, I'm just talking through it in my informal part of things. I will need to include that in my formal write-up as well. Okay, with the informal work, I'm just going to say that frees me up to replace f of x with 2x minus 2. And I'm just going to simplify that minus a -4 would be a plus 4. And I want to make that less than epsilon. And remember, with the informal work, even though this is supposed to be my conclusion, this is what I'm working towards, with the informal work, we do what's absolutely not allowed in the formal work, and we start with the conclusion and we work backwards. Okay. So notice this becomes the absolute value of 2x plus 2 being less than epsilon. I'm going to factor out that 2. Absolute values distribute over multiplication, so that's the absolute value of 2 times the absolute value of x plus 1 being less than epsilon. Notice I was careful to keep that in absolute values here. In our last example, we had a negative number there. It is true that the absolute value of 2 is 2, so this becomes just 2 times the absolute value of x plus 1 is less than epsilon. If you went straight from this line to this line, your work is correct. But I'm very concerned that if this was a -2, you would skip the absolute value and put a -2 here. And that would be completely wrong. because a negative thing cannot be smaller than epsilon, which is positive. Okay, so I write that extra step just as a check on myself so that I don't make a careless mistake and forget that I'm not actually factoring a number out of the absolute value. I'm breaking the absolute value up into two parts and evaluating the numeric part. Okay, but now I could divide both sides of this by 2, and I could say, oh, so the absolute value of x plus 1 needs to be less than epsilon over 2. That is my candidate for delta. Okay, excellent. So now I need to do the formal work to prove that this delta actually does work. And much of what I do in this formal proof is going to be incredibly redundant because it's going to be the same algebra. The difference is it's going to be justified. Everything I just did in the informal work was unjustified because I started with my conclusion assuming that it was true. Now, I was kind of hoping it was true and trying to find something that was equivalent, but I need to now, in my proof, I'm not going to start with an inequality. I'm going to start with an expression, manipulate that, and then show that something is true about that expression. Okay. So, let's see. Formal proof. Just going to indicate that that's starting right here. So, let epsilon be bigger than 0. Let delta equal epsilon over 2. Okay. So remember, the first 2 lines are just to acknowledge the challenge and then say how we're going to beat it. We introduce epsilon, we introduce delta. And we have to introduce epsilon first because we're describing delta in terms of epsilon. And now I want to prove this if-then, that if my delta inequality is true, then my epsilon inequality is true. Okay. So I'm doing a thought experiment. I'm going to suppose the if part. That's like walking into my lab, making the if part true so that I can then sit back and observe what follows from that. So I'm going to suppose that 0 is less than the absolute value of x minus a negative 1 is less than delta. Now here, I'm going to need to use both parts of that inequality. Okay. So I'm going to say that I know that 0 is less than the absolute value of x minus a negative 1. If the whole thing is true, then just this part is true. That tells me that x isn't negative 1. Now what I want to use that for is to replace this with a linear function. Okay. I want to include the algebra that justifies that as part of my formal proof. Okay. So, observe that f of x is 2x squared minus 2 over x plus 1, which is 2 times x plus 1, x minus 1 over x plus 1, which is 2 x minus 2 if x doesn't equal negative 1. Okay, so I do need to make sure that I have this work here. Now, I'm okay if you already had it on your paper, if you put a little box around it and put a star next to it, and then instead of copying the exact same work here, just wrote by that star, this is true, and just draw an arrow to include it. But it should be part of your formal proof, and that does need to be indicated. All right, okay, so since x does not equal negative 1, which is what we had right here, I know that f of x, for the purposes of this problem, is 2x minus 2. Okay, I also know, so from this supposition, I've now used this part, now I'm going to use this part. Okay, so I think I'm just going to erase this so that I've got this part of the board to work with. Okay. Also, the absolute value of x minus negative 1 less than delta implies, I can use this implication arrow if I like to. That just says if this is true, that can be simplified to the absolute value of x plus 1 is less than epsilon over 2. All I did here is say subtracting negative 1 is the same as adding 1, and since we'd introduced that delta was epsilon over 2, I can replace it with that. Now I know I'm going to need to refer back to that later, so I'm going to call that, I'm actually going to call that double star, because I think I'm going to call this star. I'm going to need to refer back to that as well. Okay. So I'm going to use the word consider the absolute value of f of x minus a negative 4. That's just a nice transition word to say, now I'm ready to talk about this. And here's what I want to say about that. The absolute value of f of x minus a negative 4 is going to equal, whoops, I'm sorry, this here should have been 2x minus 2. I think I'd written just 2x. Should have been 2x minus 2. That was what f of x is if x isn't negative 1. Okay. So I'm going to replace f of x with 2x minus 2, and then minus a negative 4 would be plus 4. And I'm just going to put a little star here to say, hey, I'm referring back to this. This is what justifies my replacing f of x with 2x minus 2. But now I can do some arithmetic. That's going to be the absolute value of 2x plus 2. That's going to be 2 times the absolute value of x plus 1. Notice this feels very familiar, but the difference is I'm not saying anything about it that I can't justify. I'm not saying already that it's less than epsilon. I'm just doing some algebra to simplify it. So that's the absolute value of 2 times the absolute value of x plus 1. That's 2 times the absolute value of x plus 1. So I'm taking really small steps here so that it's clear why each thing is true. Now I'm ready to use double star. I know that this quantity is less than epsilon over 2. So I can say this is less than 2 times epsilon over 2. And I'm just going to put a double star here because this is a little less obvious why this is true. This is referring back to something that I'd stated earlier in my proof. But now those 2's cancel and that's epsilon. So what we did is we started with this expression. It was equal to everything up until here, so we're still talking about that same expression, and then we showed it was less than something that was equal to epsilon. So it's less than epsilon. That's what we needed to show. So we've accomplished our goal. Again, this is a convoluted enough process that I like to just say, thus, the limit as x approaches negative 1 of f of x is negative 4. That just makes it super clear to my reader that the reason I stopped was because I was, in fact, done. I had accomplished my goal. I wasn't just tired or bored or confused. Being done is a good reason for stopping.